gases and spores can pass to the streaming air and then result in cross-contaminations. So we have filters, but we need to find also ways to disinfect filters. Otherwise, we may have to replace them, which means higher costs. Now, again, if we check in the literature, filters that have been used, especially in other type of industries, not necessarily in food industry, they were trying to address this disinfection cleaning approach through different methods. And there are chemical methods, so they were using different solutions. It could be in the form of aqueous solutions, so based on ozone, based on organic or inorganic acids, and try to clean these filters and continue reuse them. In these cases, they may have to remove them, clean them, and put them back. There are other cases which are quite interesting. They use the benefit of EU radiation, and depending on the particles they may have coated on the filters, like for example, if they use titanium dioxide, they can benefit of the photocatalysis, and then they activate these antimicrobial properties of this titanium dioxide. The other possibility that we try to focus more in this type of project was actually to coat the filters with nanoparticles. And if we were coating well enough, we would expect actually to see that if we manage to trap the molds or the fungi which are present, and we have these nanoparticles, they may have possible antifungal properties. So again, there are criteria for that. There are criteria to choose the filter. There are criteria to choose a cleaning agent or a cleaning method. It's again the costs. You have to make sure that if you are using some chemicals, they are not corrosive as well. So this brings us to our objectives. So we wanted to actually develop novel filtration systems that they should be efficient, and they have also antifungal properties. So if you manage to trap some spores, you also don't allow them to grow on the surface, because what is happening a lot, and you see it also on corners or on the exits of the